Hello and welcome to another Monday night Q&A. I'm joined tonight by my colleague George Giorgio from the Technical Helpline team. Good evening, George.
Hiya Sam, how you doing?
I'm okay. How was your Monday?
It was good. Very eventful, busy as usual, but can't complain.
Yeah, Mondays are always off to a flying start, always.
Yes, for sure.
So, as with all of our live Q&A sessions, I'll just run through a few house rules. We'll start off with the question of the week that we posted out across social media channels earlier today. And we'll go through our answers to that question. And then while you're putting your questions into tonight's chat, we'll go through some of the questions that we didn't get round to asking for or answering from previous sessions. So please, when you're ready, start to put your questions in the chat. Remembering the golden rule, no such thing as a stupid question, only stupid answers. Whilst you're in the chat, please remember to be respectful to each other, as the whole idea of this evening is to collectively help each other with the aim of improving our knowledge of all things BS 7671 and the world of electrical installation. So, without any further ado, we'll just have a recap of this week's question of the week. So, the question of the week that we posted earlier today was, for compliance with BS 7671, which of the following connection types must be accessible for inspection, testing and maintenance? And the four options that we gave everybody was a joint designed for burial, a BS 60670 junction box, C, a welded joint, or D, none of the above. Do they all have to be, are they all required not to be accessible? So the question was, which of the following connection types must be accessible? So we'll just take a quick look at a poll. When I checked our responses earlier this evening, about 6 o'clock, this was the poll results that we were getting at that time, which was saying that over 70% of the people were saying that it was answer B, a junction box to 60670. There were a few, 21 went for none of the above, and a very small percentage, 2%, said that a joint designed for burial must be accessible. So the actual answer is, as with the majority of people, the actual answer was B. The type of connection which must be accessible for inspection, testing and maintenance out of that list was a BS 60670 junction box, an old style junction box. And where are we deciding that answer's from? So let's just give you a little look at that. One's really driven by regulation 526.3. so George, what kind of things does regulation 526 tell us that we can make sure doesn't have to be accessible?
So well said, Sam. So regulation 526.3, guys, gives you a detailed list of everything that requires inspection, because if it's not on that, if it's not within the 6 items that you see on the screen, it requires inspection and future maintenance. So, anything that's on that list does not require it. And the simple reason comes from the manufacturers. So the manufacturers allow, through their instructions, they design their product in such a way that when your connections are made, there's no risk of the cables or conductors getting loose in the terminals or anything like that, which gives us comfort that the connection will be permanent.
Yeah, absolutely. And that's the issue, isn't it? That there's the potential with screwed terminals, that the screw could become loose. The cable, if it's prone to movement or vibration, could come loose within the terminal. So that's why they need to be available for inspection and test. just a little bit more if we're looking at what those two standards that we've referred to are. So the first one that was the item B, BS 60670. These are the old traditional style junction boxes, 40 amp, and I can't remember what the smaller one with the four modes was now. 32 amp, because I think it was used on a spur, but I'd need to look. I'll be honest. It's been a long while since I've used those old style junction boxes. And the key thing was there are types now which can be made inaccessible. So these are the ones, for example, that if you did a repair and you wanted to bury the repair in the fabric of the wall, that you'd use the junction box, which doesn't have to be accessible for future maintenance and test. It's very important that it's designated as maintenance free. It has to have that symbol. So as you can see on the slide there, the MF in the circle. This example does actually reference the standard as well, BS 5733, and it also actually says in text that it's a maintenance free connection. So they've sort of gone triple wise there, but yeah, you only have to have that MF.
If you are in doubt, guys, whether or not a piece of an electrical connection that you're looking to make needs to be accessible in the future, always refer to the manufacturer's instructions. If you are ever in doubt, that they will always be the ones to give you the answer. It's their product. So if you're ever in doubt, our regs state to take account of the manufacturer's instructions, so you're doing everything right.
Okay, brilliant. Right, so we'll just have a look at some of the other questions while we get some populating into the chat box. So another one that we've had in the past, and one fairly common for this type of year, at what depth should a cable be buried for domestic garden lighting? So lots of people now looking at doing additional work and upgrades around the house. Garden lighting comes out in the summer always. So George, what can we tell people about what depth should a cable be buried for domestic garden lighting?
Well, it's a good question, Sam. So when we're looking at what depth a cable should be buried in the ground, we need to first assess the situation, because asking that question is so vague in itself that it's almost like asking how long is a piece of string, right? So depending on what the use in the future, the foreseeable disturbance of that ground, whatever that's likely to be, whether it's a lady at home wanting to put a plant in the ground, or whether it's an extension and they're looking to dig 1.5 meters into the ground. So when we're looking at cables buried into the ground, it should be at a sufficient depth to avoid any foreseeable damage in the future. And that comes from regulation 522.8.10, ladies and gents. So that regulation, it physically can't give you a depth because it's all relevant to the installation, you see. Do you want to add anything to that, Sam? Or?
No, that's spot on. That's spot on. I think there are some figures quoted in terms of general garden. So if we're looking at, you know, an area that's general gardening, so you might get a spade put into it, but that'd be the most onerous thing. Then a depth of 0.5 meter is recommended as being sufficient to avoid damage. But as you've very rightly said, it really does take a little bit of an assessment as to, okay, well, that's where I want the cable to run, what's likely to happen in that area, and then bury it deep enough so that it's not going to be damaged. Of course, always use warning tape or cable covers as well, so that even if it does start, hopefully they will get identified first before the cable is damaged. Okay.
And again, if you're ever looking to install a cable into the ground, just to sort of follow on what Sam's just said, it's always a good idea to communicate with your client as best as you physically can, because you may not know what the future plans are. I personally, from experience, gone to jobs and put cables in the ground in gardens, and if I never communicated enough with the client, I wouldn't have found out that they're planning to do an extension in 6 months and things like that. So communication is key.
Yeah, very true, very true. Another favourite. So when carrying out electrical work on an installation forming part of a TNCS system, is it necessary to upgrade existing 6mm squared protective equipotential bonding conductors to 10mm, obviously with 10mm being the current requirement? So on an existing installation, would we have to upgrade those, George?
So to answer your question, the answer is no. No, you don't, because it's existing, and more than likely it would have it would have been installed at a time when it would have been compliant. So it's not something that would need to be upgraded. And we have best practice guide 4. So for those that are doing EICRs on a regular basis, best practice guide 4, I would say, is our mother in the electrical industry for EICRs at the moment, and what we follow. It's the industry standard for EICRs. And it's quite important to be familiar with that, because it does cover you. And on that guide, Sam, it does state, like what we're sort of talking about now, that it doesn't warrant a code, and it's an item that they say is worthy of a note, but does not necessarily warrant a classification code. So it's something that is always good practice to detail on the comments of the existing installation and things like that. But it's not something that you necessarily must or have to upgrade. And I think we going without over talking, but I think if you look at regulation 132.16, it's a good regulation to have in your locker, because it says no additions or alterations shall be carried out unless the earthing and bonding is adequate. So they're not saying it has to be up to current regulations, they're just saying it needs to be adequate, and adequate just means safe.
Yeah. So it's a good idea, isn't it, to do as much investigation as possible. So mostly that's going to be visual, to make sure that the 6mm isn't showing any signs of thermal damage, isn't showing any signs of other forms of damage, and then like you say, document it clearly on your condition report to say that existed already. It's not something that you've done. However, you've done everything reasonably practical to confirm that it's adequate for continued use. Another good one, where we do get C2 classification codes against an observation on a condition report, how long is deemed acceptable to carry out the required remedial action in order to make the installation satisfactory? So maybe you've done the condition report and you've allocated a C2 classification code, or alternatively maybe you're being passed a condition report and being asked to do the required remedial work. So what's considered an acceptable time to carry out that remedial work, George?
Okay, so if there's a C2 on an EICR, from a regulatory standpoint, it's said to deal with the matter. It should be dealt with as a matter of urgency, because it is potentially dangerous. We do have the private rented sector that talks about getting C2 codes dealt with within 28 days, Sam. Obviously, although that's stated mainly for the private rented sector, it is still considered a good, reasonable time to get it within 28 days, even not in the private rented sector. But as a matter of urgency, it should be done no more than 28 days.
Yeah, absolutely. So it's a good, like you say, it's a requirement under the legislation for the private rented sector. So it's a good rule of thumb that we're suggesting you can use as for consideration for other instances as well. Okay, we're getting some questions in the chat. We'll just take one more from the question bank. Again, another inquiry. Can a new circuit be added to an existing domestic consumer unit if the consumer unit has a plastic enclosure? So can we add circuits to a plastic board, George?
Well, Sam, this falls in a similar bucket to the 6mm bonding cable that we were discussing. It's a similar principle. Obviously, the plastic consumer unit within a domestic premises in today's regulations isn't what we would do. It's not under current regulations. However, providing the consumer unit itself is in a suitable and safe condition, there's no holes, adequately IP rated, in a good condition, no signs of thermal damage, and the list goes on, providing the only issue that you found is that it's not meeting current regulations because it's made of a combustible material, then no, according to regulation 132.16, we could deem that as adequate. And if we deem it as adequate, there is no reason why an addition or alteration can't be carried out.
Yeah, so what type of things would we look for particularly in the plastic consumer unit? Are we looking for thermal damage internally? Anything else that might give us concerns?
Well, my top two, Sam, would be IP rating and thermal damage. Those would probably be my top two. Obviously, thermal damage will raise alarm bells, and if it's not IP rated, sometimes with plastic consumer units, I know I've seen it where you may find there's big knockouts on the top of it, and cables have been pulled down. It's just big holes and blanks missing and things like that. In those situations, it's not great, but as long as you know the board itself is in a suitable condition, then that's sort of the main objective. So I don't know if you want to add anything to that.
Yeah, no, that's spot on. So I always use the phrase that it still provides adequate barrier and enclosure protection,
yes,
which is one of the key features. I think we've also got to look to make sure that there's been no product recalls on the items of equipment that are installed. But apart from that, yeah, it really is things that can be resolved with a visual inspection of what's existing in the board.
Thanks. And just to add on to what Sam's just mentioned with the barriers and enclosures, if you guys want to have a read, and that's regulation 416.2, which lays that down quite well if you want to have a bedtime read.
Okay, all right, we'll start to have a look at some of the ones that have come through the chat, so thank you very much for those. So the first one that I'm picking up is on a recent EICR, I found a triple pole MCB fitted L2, L3, L1 in a distribution board. Does this require a code? So we've got phase sequence incorrect. Couple of things that we'd put a caveat. So if we've got items of three-phase equipment connected to that MCB, then you'd need to look at, okay, well has the phase incorrection been transmitted further down? Has it been corrected? So you'd need to look at that, because if there are three-phase equipment connected, potentially you may have some issues there. So that would warrant, I think, a bit of further investigation. If it were just single-phase equipment coming out of the distribution board, or single-phase circuits I should say, then although we have actually got a phase rotation incorrect, it's not going to cause any danger to the users of the installation. Might be a little bit confusing to somebody else coming along to do some electrical work, but with regards to an EICR, we are really looking at safety for the users of the installation. So I would suggest, if it's single phase coming out of the DB, then it doesn't require a code, but I would suggest recording it as an observation to make it clear that you did note it. If there are three-phase items of equipment, then you're going to need a bit of further investigation to see, could that phase rotation error cause problems? If, for example, we've got moving equipment, if we've got equipment that have got safety guards on that are looking for them to be on a particular phase, for example. So a bit of a split decision as to whether it's single phase or three phase. Would you add any more to that, George?
Yeah, so not too much, Sam. I think you've pretty much hit the nail on the head. With the single phase side, yes, definitely. The three phase side, of course, it will require further investigation. We need to remember, guys, the further investigation code is given when there's not enough information to determine whether something is safe or unsafe. Now, if you have a circuit, a three-phase circuit that's got reverse polarity, but it's consistent across the whole circuit, then we need to be asking ourselves, okay, the equipment connected to that, is that safe with the polarity that it is, or could it cause a safety concern? And this is where the FI code that Sam mentioned would be very useful. This is where it comes in. Sam, I wouldn't add anything more. I think you've hit the nail on the head.
Okay, good. I just had to grab my my best practice guide 4 for a minute, so that was what I was reaching across for, because I just wanted to make sure I was going to say the right thing on this next one. So we've got a question. Evening lads, as it stands at the moment, is no surge protection in a domestic property a C2? So at the moment, if we're doing a condition report based on 18th edition amendment 1, then we would be going by current version of best practice guide 4, which for this instance, lack of surge protection, suggests that it's an item worthy of note, but doesn't warrant a classification code, providing there's no medical equipment, so we're not talking about injury or loss of life if we lose the supply, and providing there's no expensive electrical equipment. If there were either of those two, then best practice guide 4 suggests it's recorded as a C3, i.e. not dangerous to the users of the installation, but could be improved to meet current requirements. Now I've caveated that with current version of best practice guide 4 and BS 7671 2018 amendment 1 2020, because we know things have changed, and we're just working on what those changes mean with respect to classification codes, and we will come back out to you with that information once we've got. Any more to that one, George?
So that's come from best practice guide 4, like Sam mentioned. Again, that is our industry standard for EICRs, so can't emphasize it enough. If you do EICRs in your day-to-day work, print it out. It's a free download, have it in the van. But just to add to that, because I'm sure that this is also a question that's going to be added on to that, Sam, AFDDs, because it may be raised if there's no AFDDs as well, what sort of code, and they're actually next to each other on best practice guide 4 with this information. They're both items that are worthy of a note, that do not warrant a classification code. But the only difference is with an AFDD, if it was in a wooden constructed domestic property like a barn conversion, some sort, you could consider a C3. So I just know that AFDDs and SPDs, sometimes the questions are quite matched. So if you're wondering about AFDDs, that's basically would be your answer.
Yeah. Okay, another one that's coming through the chat. What code would be given to a split concentric cable that's had the outer sheath removed, leaving basic insulation terminated into the load side of a one-shot isolator? The isolator is mounted next to the meter in an external meter box. Okay, so a couple of things here is generally we suggest that whenever you've got single layer of insulation accessible to touch, then we would suggest it's a C2. If you've got a single layer of insulation which isn't accessible to touch, then we'd suggest a C3. So in this instance, it's very much down to the adequacy of the meter box to form an adequate enclosure. So if the meter box is in good condition, i.e. it's lockable, and there's no openings that you can get access to that conductor, then we'd suggest a C3. If it's in poor condition and you can actually gain access to those single insulated conductors easily, then we'd suggest a C2. Happy with that one, George?
Yes, spot on, Sam. Nothing to add to that.
Okay, we've then got some comments. I thought it was C3 as not mandatory. I think they're referring, as we said, to the surge protection device. Thank you very much for the engineers that have corrected me. 20 amp junction box, old style. It was the 20 amp one with 4 terminal pork pie box. So there's one engineer has also seen 6 terminal box. So I have to admit it's a good while since I've seen them, so I do apologise and thank you very much for the help. It's always welcome. Okay, we have a 12 volt bed head light with single insulated cables from it, black and white. These cables run through a furniture bed head section to a connection unit. There are no LV cables in the bed head section, so completely running on their own. Do these cables need to be double insulated or run in a Copex? They came single insulated from the manufacturer. Okay, interesting one. 12 volts obviously would take us below the threshold of 50 volts, so we're now into extra low voltage, which could perhaps give us a benefit, but we don't know if it's for example salve, which we could use as a protective measure. So yeah, perhaps a little bit of investigation with the manufacturer's information, because it could be that they're using salve, for example, as their protective measure, in which case then you wouldn't need to do anything. I'd also be interested to see what the manufacturer said about single insulated cables being adequate for the environment, because normally that would mean they've got insulation for protection against touch, but no protection against mechanical damage. So you know, if we've got any movement, for example, associated with that bed head, you might want to think about possible stress and strain on those cables, even possible abrasion. So yeah, a little bit unusual for them to be exposed, certainly. So yeah, I would seek some advice from the manufacturer, certainly about whether they are salve or not. If they're not, and if you believe that they could also suffer some impact damage, then we'd certainly consider providing them with additional mechanical protection. Bit of a strange one there, George. You've seen that before?
It's a good question. We do get questions like that on the technical helpline, so it's not the first time to hear that. Like you said, Sam, self and PELF, they offer basic and fault protection, so that's okay from that end. But the thing that I would the thing that would raise alarm bells for me is exactly what you just said, Sam, about the mechanical protection side of it. All it takes is a bed head moves and hits it, or you know, I mean, anything can happen. It's very open. So my advice, if this was on a technical helpline, I would advise you to consult the manufacturers, just to make sure that two things: that first thing, the install has been done the way you've installed it has been done to the manufacturer's instructions. Secondly, the location of that light is suitable for the location, for the environmental conditions that it's likely to face. So A, you've installed it correctly, and B, that light fitting is in the right place to where manufacturers would be happy to have it.
Yeah.
Now, sometimes if you have exposed conductors, sometimes they're designed to be out of reach and places like that. But in this situation, to have it right by a bed head, I'm not entitled. I would say consult the manufacturers for that, and just make sure that those two things have been confirmed.
Okay. We've got some people commenting that they would go 600 millimeters deep. I think the general guidance is as we said, you've got to look at what you're doing, and we've seen, I believe in it's either in one of the guidance notes or perhaps it's in the electrician's guide to building regs. They do talk about going deeper if you know that, for example, it's agricultural ground. So again, you know, the half a metre is generic guidance. You've really got to think about what's going to be done to that ground above. Somebody's asked, shortly carrying out fixed wire testing of a boarding school, what if any code would be suitable for lack of AFDDs for power circuits protecting the dorms? No code, as it's an existing installation. Well, yes, as we've said, currently if we're looking at the guidance based on requirements of 7671 Amendment 1 2020, we've suggested that lack of AFDDs would be something that we would note but wouldn't warrant a classification code, because in general we try retrospectively not to put things back. So again, on that one, right now we'd be saying providing you've got adequate fault protection and the required additional protection for things like socket outlets, then we would suggest it's something worthy of note, but doesn't warrant any further classification. We've got some comments about guidelines for bonding conductors being 16 mil when it was done by the old electricity boards against PME, and given DNOs love to throw the rubbish over the fence. Yeah, we do sometimes need to stand up about what's been done by our DNO partners, and make sure that they're doing what they need to do. Don't forget their regulations are statutory, so we need to be pulling them up if they're not doing what they should be doing. Another engineer has commented, I think, on the consumer unit question. So what about if the consumer unit is located under a single means of exit, as in under a staircase in a domestic situation? Yeah, you're absolutely right. In that situation, we would suggest it's a C3, so that would be a strong recommendation to upgrade it. So if for example we had a plastic consumer unit, it was either in a single means of escape from the domestic property, or it was in the area of high combustion risk, I think the example given is under a wooden staircase, then we would suggest it's a strong recommendation to upgrade it, even if it is, as we talked about earlier, fit for purpose. There's no thermal damage, there's no signs of product recall, but again, it wouldn't be a regulatory requirement to upgrade it to add the circuit, but we would suggest recording it as a recommendation, making it clear if the consumer unit owner or homeowner decided not to do it, that you had strongly recommended it. Let's have a look. Can a ring main wired in steel conduit, with the conduit being the CPC, be extended via PVC conduit and a copper CPC? Absolutely. No reason why not. You would need, we would suggest putting some additional information on your installation sheet or your installation certificate or minor works certificate to make it clear exactly what you've done. You're still going to need to meet the ZS requirements of your protective device. You're still going to need to meet the requirements of the of a good old friend, the adiabatic equation, but yeah, there's nothing that would prohibit you from doing it. You'd need to think about how you're going to ensure the durability of that connection, so that's something else that would need to be considered. You know, effectively how you're going to transition from the metal conduit to a copper conductor, but perfectly acceptable. No reasons why you can't do it. Can you see any reasons why you couldn't, George?
No, not at all. I mean, conduit is still a CPC that is used for circuits. There's no issues with it, and actually it can afford quite a low resistance value and a nice return path in a lot of situations. So, like Sam just said, as long as you're going from sort of copper to steel, as long as you can work out the difference between steel to copper resistance values and ratios and things like that, and make sure that it's okay in that way, then that's absolutely fine.
Yeah. Okay. If you're classing the meter box as an enclosure, what's the non-compliance of having single insulated conductors contained within? Does the meter box meet the requirements of BS 7671 as an enclosure? So yeah, valid points. If you look in definitions in part 2, you know, a good robust meter box that's in good condition and fit for purpose will meet the requirements of an enclosure. So that's where we were saying that if you believe it's adequate and it provides the correct degree of protection, then single insulated conductors within we would suggest would be coded as a C3. If, however, for example, there's a huge hole or the door's hanging off and you can have direct access to those single insulated conductors, that's where we see it would be a C2 and potentially dangerous, because now we're reliant on a single layer of insulation as our means of protection. Hi Hi guys, we install EV chargers and we install the fire rated clips if a cable passes over a garage door, etc., but have been asked on occasions to install these at low level where they pass an exit or entry route. Is this a requirement of 7671, please? So 7671 talks about it being a requirement to prevent premature collapse in the event of a fire. And if you look at the informative note 1 under that same regulation, it talks about this is to ensure that you're not detrimentally affecting evacuation from the property or firefighting activities. So those are really the key things, which is why, for example, if you've got cables that aren't going to do either of those two things because of their location, so they're never going to be able to prevent evacuation, they're never going to prevent firefighting activities, then there would be no need to put those additional fire clips, so metal clips. So it really does depend on what it is, and have a look strongly at the informative note 1 associated with that regulation. Anything else you'd add to that one, George?
Not really. So I think you've covered it. Like Sam said, it's an engineering judgment. We can't paint all installations with one brush. If you're ever in doubt and feel that those cables melt, say the support's melted and the cable collapsed, if you was ever in doubt, always take the side of caution would be my recommendation. Because you don't want to take any sort of risks in this game, but yeah, it comes down to an engineering judgment. Most of the time you'd probably be looking at providing adequate support to prevent the premature collapse in the event of a fire. There are the odd occasion, but again, if you're ever in doubt, take the side of caution would be my advice.
Okay. And lastly, was there a mention the other night in your training regarding using type B RCDs and type A? If there is a true A at the front end and in the charger they've incorporated a type B, is there an issue with this? Well, potentially, because we've got a type A will be limited to 6 milliamps of DC leakage current, and a type B will cope with more. So what you need to check is if they've installed a type B within the charger or at the charging equipment, because the manufacturer of the charging equipment has made it clear that their equipment can leak more than 6 milliamps of DC leakage current, then unfortunately your type A back nearer the origin of the circuit could well be, for want of a better phrase, blinded by that leakage current. So you in terms of selectivity, you have to have them correctly. So we could have a B at the origin and an A further down stream towards the load if we wanted to. So B at the origin, A at the load. You can't have it the other way round, because although the B at the load would be tolerant to DC leakage currents greater than 6 milliamps, it won't block them, so it won't prevent those same DC leakage currents travelling up the circuit to the origin and potentially blinding a type A or even a type AC at the origin. So that's why you need that selectivity. Okay. Crazy time goes again, so we'll just finish tonight with on a domestic condition report, what classification code should be given to meter tails which are over 3 meters in length? So where we've got our consumer unit distanced from the DNO cutout such that the meter tails are over 3 meters in length, would that warrant a classification code on a condition report, George?
Yeah, so although the DNO would typically not agree to have their cutout fuse being used to provide overload protection to the meter tails in excess of 3 meters long, the situation isn't actually or necessarily dangerous, Sam, or potentially dangerous to the users of the installation. So you need to bear in mind that if it's not dangerous, we need to understand that an EICR, you've got to look at it from a safety lens only, safe or unsafe. That's kind of the only way we're looking at things. And although it's over 3 meters, even if the DNO don't agree, it doesn't suddenly put it as a safety concern. It just means they don't agree. So we wouldn't be looking at a code for that, although you could make a comment or leave a comment on your EICR, but whether an actual code is needed, I wouldn't say classification code would be majorly required for that. No.
Yeah. So it's unless there's evidence that the DNO have agreed to that extended length of tails, it would be non-compliant. But as you say, just because it's non-compliant doesn't actually make it dangerous or potentially dangerous to the users of the installation. So you would need to check things like, okay, well, am I still within the ZS of the overcurrent protective device in the service head, so that my tails aren't that long, and then will that provide adequate disconnection in the required time in the event of a fault? Have I got adequate overload protection for the tails based on the either the overcurrent protective device or the maximum demand of the installation? So there's some other things to consider, but just because we've got that extended length doesn't mean that it's unsafe for the users of the installation. Okay, before we go, what we want to do is some of the questions there tonight. There's some very useful free industry accepted advice that you can gain from Electrical Safety First website. So if I just show you, if you go on to the website, you've got the web address there. There's some really useful information, 2 sets of frequently asked questions. The first set is associated with new, rewired and similar installations. So that's your new work, new installations, additions and alterations to an existing installation. And you can see the people or the organisations that participate in the Electrical Safety First. So it's ourselves along with other competent person scheme providers like NAPIT. You've got other key organisations, ECA and Select, awarding bodies like City and Guilds and EAL, the IET themselves, BEMA, the British Equipment Manufacturers Association. So some really solid firms associated with the electrical industry that contribute to these. And there's a second website or page on the same Electrical Safety First website, which looks after inspection, testing, certification and reporting. So lots and lots of resources there for frequently asked questions, available to everybody, and can really be considered industry guidance. So if people are questioning you, it's a really good source of information that we often use to show people that this is where we got it from, and it's not our personal opinion, but it's the situation of it's accepted by the industry. Also want to make you aware that we've got another WIRE webinar coming up. So that's a week on Wednesday, the 13th of July. The subject is electrical safety checks for the UK rental sector, because there are some changes coming up after a long while since the PRS scheme became legislation. So there's now some further changes coming up. And then lastly, just want to make you aware that we will have another Q&A in a fortnight's time. That will be Monday the 18th of July at 8 o'clock. I do apologise if we didn't get round to answer your question tonight. Thank you very much for contributing and putting the questions in the chat. Any that we didn't get round to tonight, we will sweep up and we'll use those to start off the next session on the 18th. So how was that 45 minutes for you, George?
No, it was good. It goes really fast, doesn't it, Sam?
I'm always amazed.
Really fast.
It's the It's the quickest 45 minutes of my fortnight every time. It does go amazingly quickly.
But I just want to sort of follow on from what Sam said. Just say a big thank you to everyone who's been on the live with us, taking the time out of your Monday evening. But you could probably be doing better things, but you know, you've taken the time out, and we appreciate it. And the questions are good questions, and just keep them coming. I'm on the technical helpline side, guys. So if you guys have any technical questions, you know, feel free to give us a ring on the helpline if you're registered with us. And that's it. Just a big thank you for jumping on.
Yep. No, thanks very much, and always good. And hopefully we'll meet you again on another session. Thank you very much.
Cheers, guys.